So to continue with our example where we were determining whether or not aggressive video games leads to a lack of empathy with respect to the rating scale, we went through, we computed and constructed the frequency distributions for week 0 and week 3. And so what I did was I just copy and pasted what we did into Excel and just kind of made the diagrams a little bit nicer for us to read. And so for part C and D, we're going to make 2 histograms, one for the week 0 data and one for the week 3 data. All right, so let's see if we can do these side by side, hopefully. So here's one, and then here's another. Now we might have to write really small to be able to fit these in. I'm just going to abbreviate frequency, frequency, frequency. And then these are going to be the scores. All right. And we have, the highest we have is 5 on either. So let's just go back, make that up to 5. All right. So the first one is from 5 to 9. And then we have a 5. And then we have another 4. And then we have a couple of 1s. All right. And so this is going to be our 5 to 9, and then 10 to 14, and 15 to 19. All right. And then 20 to 24. And then finally we have 25 to 29. All right. And this is, I'm just going to say that this is the week 0 scores. All right. And again, I'm just writing that in there a little bit briefly just because of time. And we're going to do the same thing on our second. So we have a 5 as our highest. So we're going to go up to 5 here. And then we have another 5. And then we have a 3. And then a 1. And then a 1. All right, so this is going to be our 3 to 7, and then we have a 10. Oh, this should be not 10 to 14. Excuse me. These are the right frequencies, but this should be 8 to 12, and then this is going to be 13 to 17, and then 18 to 22. And then 29, or excuse me, 23 to 27. All right, there we go. So sorry about that. Again, these are the correct frequencies. You can check the previous video. So this is going to be our 8 to 12. And then we have 13 to 17, and then we have 18 to 22, and then 23 to 27. And this is our week 3. Now, if we were to describe the shape, center, and spread of both of these, because it does ask us to do that, notice that, and this was part C and this is part D. Notice that this is just going to be unimodal. More data is on the left than the right, so it's going to be skewed left. And then finally, we notice that there's no gaps, so no outliers. And we probably recognize that in the second histogram, that once again, it's unimodal. Okay, so this constitutes one peak. All right, so it's still unimodal. And then it's again skewed to the, excuse me, this should be skewed right because there's more data on the left. Excuse me. This is skewed right. This one's skewed right as well. And again, there are no outliers. All right, so now does that mean that the distributions are the same? Well, unfortunately, it doesn't, because remember the scales are different. This one starts at 5 and ends at 29. This one starts at 3 and ends at 27. So even though they look like they're relatively the same histogram, notice that the distribution scales are different for this. All right, so we have to be careful when we're interpreting these. even though they have the same characteristics, that doesn't mean that they have the exact same output. Okay, so hopefully that makes sense. Now we have to construct a dot plot for both. Okay, so what I'm going to do is I'm just going to copy down the original data. All right, and what I'm going to do is I'm going to basically do like a stacked dot plot. All right, so in other words, I'm just going to go ahead. I'm going to start at 0, and I'm going to go in increments of 5. So this is 0, and then we have 5, 10, 15, 20, 25, and then 30. All right. On the top, I'm going to have week 0, and on the bottom, I'm going to have week 3. And what we might be able to do is we might get a little bit better picture of how they compare to one another. All right. So I'm just going to do week 0 real quick. So we have a couple 5s, and we have a 6, and we have an 8, we have a 10, we have an 11, we have a couple 13s, we have a 14, we have a couple 15s, we have a 17, 18, 22, and we have that 28. All right, so it looks like there's more data on the left. All right, it looks like most of the data is between 5 and 20. Now, let's take a look at week 3. All right, so we're going to have a 3 here, and then a 4 and a 5. All right, and then we have a couple 7s, 8, 9. So we have a couple 7s. We have an 8. We have a 9. We have an 11, 12, 12, 14, 14. So we have 11, 12, 12, 14, 14, and 15, 20, 27. So 15, 20, and then 27, which might be like right about here. All right, so if I was to look and see where the majority of the data is, it looks like that the majority of the data for week 3 is between maybe 3 and 15. And the majority of the data for this week, for week 0, is between 5 and 17. So it looks like it shifted a little bit down. Okay, so if I was to draw like this sort of encompassing creature, if you would, like this, all right, we can clearly see that there's a disparity. All right, but we don't know how big of a disparity this is. All right, in fact, when we start looking at other sorts of measures, that's going to tell us a little bit more. All right, but from this, it looks like that they're not too different, but they're a little bit different. All right, so the question is, now that we've done this, and this is part E, and this is part F, I just stacked them on top of one another. The real question is, based upon everything that we've looked at, suppose somebody makes the claim that prolonged exposure to violent video games decreases one's empathy. What would we say? Well, first of all, the sample size is 100, okay? But from that sample, we selected 15 of each week, okay? So the sample sizes are pretty small. Okay, so sample sizes are somewhat small. All right, so again, we always are concerned with our sample sizes, all right? In other words, does it really reflect what the population is saying, all right? Another thing that we have to be concerned with is that even though we were doing a cohort observational study, and we said that cohorts are a little bit stronger, we really only did a cross-sectional study twice because we had week 0 scores and then week 3 scores. So we only looked at 2 weeks of data. Okay. So what about week 1? Week 2? Week 5? In other words, does the trend continue? All right. I mean, it looks like it's slightly decreased. If we go back to these, okay, we can clearly see that from the classes, yeah, we went from 5 to a 3 and a 29 to 27 for the highs and the lows. But in between there, it doesn't look like it changed all that much, right? Another thing we have to consider is that the observations were taken from a cohort, but are not really cohort data, or is not really a cohort study with just 2 samples. All right. So a cohort study is one to where we might have week 0, week 1, week 2, week 3, and then we just follow it over a longer period of time. All right. So based on all of this, we might not necessarily be able to justify the claim. Okay. So there's not enough evidence to truly either support or refute the claim. All right, so what we would suggest is that we might need more weeks of the cohort to truly gain perspective. All right. Another thing that might be helpful is to be able to do a multi-step sort of sampling to kind of give it a little bit more randomization. Okay, so perhaps a multi-step sampling could be used rather than just the cluster. Right? So these are all things to consider. Okay, we collect data, all right, but one instance of data doesn't necessarily prove nor disprove. Okay, we have to have more data, we have to have a larger sample size, we have to make sure that our selection methods are accurate. All right, so hopefully this helps you to understand at least how to get a small snapshot of data. All right, now when we start the next chapter, what we're going to do is we're going to move away slightly from graphical approaches, and we're going to start looking at numerical approaches, which are a little bit more accurate, or let me rephrase that, are a little bit more telling of what the population might actually look like.